It's not very usual to get a good bonding between thermoplastic and thermoset material.
Yeah.
You're locally overmolding it to have additional functions.
ANYBRID builds flying injection molding machines, and we use these to overmold around complex structures. Tell us how we do it. Hey, what's up? How you doing?
I'm fine.
So, I've actually made a video a while back, and I've been talking about the work that you've done with ANYBRID. And I had this video of you with your flying injection molder. So that's why I was so excited to get to see you guys here at JEC. I'm quite keen on knowing, what do you do as a company? Like how did you get started? What are you excited about as a company?
We founded the company ANYBRID 5 years ago, almost 5 years ago. And the core product is our flying injection molding machine, as you just said it. And the idea is, we've been working in the field of thermoplastic composites for 15 to 20 years in different applications and designing processes. And
was that as part of a company, or was it outside of a company?
As a research institute. At the TU Dresden.
Okay.
So our main focus was on automotive applications, aviation applications, and we've designed big molds, big processes, big designs, but we always thought that the principle of getting a hybrid components, overmolding applications can be a better solution to all this. So because you always need big machines, big molds, so we designed a machine that is so light, and a complete injection molding machine so light that you can mount it on a robot, which makes it fly.
Oh, very cool. So I see you've got a couple of different parts. Would you like to show us something you've been working on?
Sure. Well, it's always a thing like showing this machine that is kind of disruptive technology. People come here and always say, well, oh, that's a great innovation. I've never seen something like this, and why did nobody else have that idea before? So for us, it's always very important to show what potential applications you have.
Absolutely.
What materials you can combine, what parts you can produce. So if you look at the different parts, it's always like a combination of thermoplastic material overmolded with our system using thermoplastic systems. Or it's a broad range. If you use thermoset material, you can even use wood or metal.
So you're talking about overmolding thermoplastic on a thermoset? So you surface prepare it so that it bonds?
Exactly.
Okay, right.
For example, if you look at this part, we are cooperating with the Fraunhofer Institute. And they are preparing the laser structuring of the surface.
Oh, right.
And in the second step, we're using it to overmold our element there, to get an insert on there. And it's not very usual to get a good bonding between thermoplastic and thermoset material. So that's one solution that you can get a good adhesion.
So Fraunhofer, what they did was they laser prepped this, and then you overmolded onto that, and you're getting an actual bond between the two.
Exactly.
Okay.
That was the idea. And as I said, well, we have three main applications for our flying injection molding machine. The one is you have large, bulky components that you are locally overmolding on different positions.
Sure.
The second is you have an assembly application where you have many profiles, components that you are joining together using our system. And on the third thing is like you have a profile, an extruded profile, a pultruded profile that you are functionalizing in line and overmolding it locally.
When you do the pultrusion then, so that requires, I suppose, a thermoplastic pultrusion, is that correct?
It doesn't have to be thermoplastic, it can be thermoset as well. So here at the JEC, a lot of people coming from aviation industry. So it's always the question is, can you process high temperature, high performance plastics like ULTEM PI material or PEEK materials? So
ULTEM, so that is a PEI type material, So that's a glass fiber, is that correct, which is impregnated with PEI?
Exactly. This is a profile that is produced in continuous compression molding, not from us, from our partner. And we are overmolding it locally to have some inserts placed on the profile, which cannot be produced in continuous processes. You can either use polypropylene, polyamide, PEEK material. In this case, we have a tubular That is made in laser-based tape winding.
Yeah, so you have a tape winder, a thermoplastic is laser welding it in situ, right?
Exactly.
Very cool,
Little
yeah.
tapes, and you're locally overmolding it to have additional functions. So, and both systems are integrated in one cell.
Yeah.
So on the one side you have the laser-based tape winding, and on the other side we're coming with our machine flying by and overmolding additional functions.
See, one of the big challenges with pipes is, if you look at metallics, we have very good sort of end fitting solutions that you can have with, you know, big clamping assemblies and seals. With composites, because it moves around, sealing these is actually quite hard.
Yeah.
And the fact that you guys can overmold around this, just like this, you get a seal around it. That's, in the world of, you know, even if you're looking at hydrogen or even oil and gas, that's a big problem to do the end fittings in there. And we have very complex, we have solutions, but they're expensive. And the fact that you can overmold a solution straight in there it solves quite a few problems, isn't it?
Absolutely. So just imagine you have 10 layers of tapes that you are winding.
Yeah.
And after 3 or 4 layers, you're overmolding it already inside, and then you're going on tape winding. So this brings a new perspective in the process integration.
So you overmold it, and then you can add more layers on top.
Exactly.
That's yeah, really awesome. I mean, I'm seeing so much tech that you guys have done, and you solved so many problems.
Yeah.
Oh, what do we have here?
Well, the variety of applications we are showing is very, very different. So if you look at this was a project together with LG Electronics.
LG, okay.
And they had the request to say, well, we want to overmold on a big sheet many of these inserts. And we have to do it in 10 seconds. So the challenge was to build a mold that we can reach the 10-second cycle time. So we're overmolding it from the backside, and the material and the core, the sandwich core made of plastics, are interlocking, and so we get a really good connection. And imagine our system with 5, 6, or 7 of our robots overmolding on the different positions, reoccurring elements.
So what we have is a big flat assembly with holes in it, and what you're going is locally you're injecting from the back, and then you have another mold on the other side.
Exactly.
So then you're adding these mounting points around a very complex assembly.
Exactly. And the point is why our machine is interesting for that is because you have a variety of those sheets. Some are very small, and they're getting bigger and bigger and bigger, and you can use our system to overmold all the sizes of the different elements. And that's one of the key points of our where our machine is beneficial. When you have high varieties of the same parts. I can tell you a lot more, but one thing that's very interesting or important for us at the moment is the profile functionalization. So we developed a new system that is not using a robot arm. It's using a linear system where you have a multi-station injection molding head.
So in highly automated environment.
Exactly. When you have profiles that are extruded, pull-truded, that are going in line, and you are moving with the profile, overmolding it locally, and then you're going back and doing it again.
And that's a lot cheaper probably than having a bunch of robot arm being moved around.
Yeah. On the one hand, you don't have the space for the robot to be positioned.
Yes.
And you can multiply the productivity in having multiple heads.
Wow.
On a linear axis, which you don't have to multiply.
That's amazing. All I'm going to say is thank you so much for sharing that. I've been very excited. I've been looking forward to come and see you guys. So thank you so much.
Pleasure talking to you.
Absolute pleasure, Michael. So
thanks for your time. Thanks for the interview, and see you again.
Thank you.